Let's learn use of factor theorem and how do we factorize a higher degree polynomial. So the question is find the number of real roots of this equation, and this equation is pretty scary. It's going to put off a lot of students. However, observation skills have a lot of role to play. So first thing you would observe is the powers of x are all even. X raised to 8, x6, x4, x square. So one very straightforward thing that you can do is you could represent x square with 9 with y. So an x raised to 8 will not be nothing but y raised to 4, x raised to 6 is y cube, 24y square, 32y, and a minus 65. So what this does at the least is this is a very general fourth degree polynomial, right? So at least the mystery of it is got rid of. We just realize that, okay, so we are well versed with quadratics, with cubic. This is just a little more higher degree polynomial, a fourth degree, right? So that takes the sting away from it. Now we want roots of it, real roots. So we are going to think of factorizing it, and that is what we are learning today. Now how do I factorize it? So factor theorem comes into picture. So what we do is we will try to plug value of y such that this becomes equal to 0. So we are trying to search for a factor. Okay, it is a sort of hit and trial, but it's not blind. So the way you do it is you first try to plug in y as 1 or minus 1. So you just take the coefficients without the sign. So this could even be a minus 1. Y raised to 4 could be minus 1. That could be imaginary roots. Okay, so you just take a 1. Don't think of a plus minus. You just take an 8. Ignore this 24. This is a 32 and not a minus 32, but this is a minus 65. You cannot change this, right? Because it's a constant, there's no variable there. Now, can you make it 0? The advantage of writing it this way is you can immediately see how it can become 0. Yeah, if this is negative, the only way this negative can be compensated is when all of these are positive. If any one of them become negative, the negatives are very large and cannot be compensated to make it 0, right? So if I just add this up, this is 56 and a 965, bingo. So if all of these are plus, right, this turns out to be 0. Now how do I make all of these plus? This minus 32 should become a plus 32. So y is nothing but a minus 1. Now what I also want to do is don't use this cosmetic effect. Work in the original one. Just think of x square. So if I put x square to be minus 1, this will become a plus 32. And if x square is minus 1, x raised to 4, the square of it is going to be a plus 1. Does a plus 1 into 24 make a plus 24? Yes, the rest all things will fit on its own. You just need to get a start, that's it. And what will x raised to 6 be? Think and answer, right? X raised to 6, you could say is cube of x square. So which will remain a minus 1. Or you could say is a product of x4 and x2, which the product is again a minus 1. And would a minus 1 make this a plus 8? Perfect, right? So x square is equal to minus 1 would make this 0. So we were lucky, but then luck favors the brave. Who could have seen beyond this as a very scary looking expression would have got started this way. And now comes the second part of this video. How do you factorize it knowing that there's a factor? So if x square minus 1 is a root, then we know that x square plus 1 is a factor, right? So this can be factorized as this, right? So now we need to match the coefficient. So pay attention, students. Yeah, x square you need an x raised to 8. So x square into what will give an x raised to 8? It has to be an x raised to 6, right? Now a little fast. These two is x raised to 6. X square and the next term should result in something such that the sum becomes a minus 8x raised to 6. I have a plus x raised to 6. So I need a minus 9x raised to 6. If this needs to be a minus 9x raised to 6, this will be a minus 9x raised to 4. We are going to do this 3-4 times. So if it is a tough year, either pause it, get the idea, or continue listening. This is x8, this is x6, this is minus 9x6 becomes minus 8. So we have balanced this, we have balanced this. Now the new term. This and this is a minus 9x raised to 4. X square and this term here should be something such that the net result is a plus 24x raised to 4. So this is a minus 9. From a minus 9 you have to go to a plus 24. So that's 24 and 9, 33 plus 33x raised to 4. If the product is 33x raised to 4, this has to be a 33x square. Right? Third time. Now, if you're dead sure about your factor, you can easily find the last term directly, but I'll still continue the same thought. So take this plus 1 and this new term is going to be a 33x square. X square into this constant will be something such that the net result is a minus 32x square. So you are standing at plus 33, you have to reach a minus 632. So that 33 you will come and a 32 more. So this is going to be a minus 65x square. This is x square, so this will be a minus 65. And if your factor was correct, then this balancing the last term becomes automatic. This into this is a minus 65. You do not need to worry about it. So that's it. So you have factorized it. Now repeat the same thing all over again. Yeah, but there's one more new thing that you can learn. So when I want to factorize this, I'll try the same way. So I'll take the coefficients 1. This could be a plus or a minus 9. This could be a plus or a minus 33. And this is a minus 65. Now there's no way that I can make this 0 with these values. Right? Because even if I take all this plus, it is just around 43. So x square is equal to plus or minus 1 will not work. Now what? This 65 is a good help here, students. This 65 can be factorized as 5 into 13, both of which are prime. So the next value that I'm going to try is going to be where x square is going to be plus or minus 5. And I'm going to do that simultaneously. So if this is a minus 65, if x square is either a plus or a minus 5, 5 into 33, 150 and 15 is going to be a 165. It could be a plus or a minus. X square is 5, x raised to 4 is going to be 25. Okay, 25 into 9 is a 225. Okay, and x raised to 6 is a 125, which will remain a 125. Now look at these numbers and see whether you can make 0 using these numbers. It's not very difficult. Don't club the big with the bigger number. Okay, that would make it 380, 400. You can't make it this as minus 400. Can I club the big with the small? So if this was a minus, these two together is 280, 290. And what are these? 160, 290. Oh, they make 290, 290. So if I make this a minus and I keep this a plus, check again. You need to be good with your sum. 220 and 60 is 280 and 10, 290. 160 and 12 is 280, 290. So it becomes 0. So again we have factorized it. Again you might say directly, and I did not even do a lot of hit and try. Just remember this, what did we take x square to be as? X square was taken as plus 5. And if x square is plus 5, x raised to 4 is going to be plus 25. And does a plus 25 make this a minus 225? Yes. And x raised to 6 is going to be a plus 125. Well, did I need a plus 125? Yes. So x square is equal to plus 5 is a solution to making this 0. And if that is a solution, so a factor is x square minus 5. Okay, and now once again we have an opportunity to do that learning process. X square, and what will give me an x raised to 6? X raised to 4. This is a minus 5x4. You don't need to write this actually. What else should you get so that the net result is a minus 9x raised to 4? You need a minus 4x raised to 4. X square is here, so this will be minus 4x square, right? And 1. So we have balanced this term, we have balanced this. Now this x square. This is already a plus 20x square. What else will give me plus 33 plus 13x square? So this is a 13x. Right? Just 13. Sorry, x square I need. So it's just a 13. Okay, 13x square. X square comes from here. And does the minus 5 and a plus 13 balance the minus 65? I said, if your factor is correct, it will automatically happen. And if it doesn't happen automatically, your factor is wrong. Now, this is a quadratic that you know, right? It's just in x square. So, find the roots. This can be factorized as just 1 and 13. The sum is not this. So, you check the discriminant b square 16 minus 52, which is negative. So here x square will be a imaginary number. And if x square is imaginary, then x is also imaginary. This tells me x square is equal to 5. So this gives me plus root 5 or minus root 5. Both are real. And this gives me x square is equal to minus 1, which is imaginary values for x. So these are the only two real roots for two real roots.